हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार और आइए स्टार्ट करते हैं क्वेश्चन रिलेटेड टू buoyancy एंड फ्लोटेशन। फ्रेंड्स, मैंने buoyancy एंड फ्लोटेशन का थ्योरेटिकल पार्ट ऑलरेडी डिस्कस किया है। आप उसका लिंक जो है मैं अपने डिस्क्रिप्शन बॉक्स में दे दूंगा, आप वहां से उसे देख सकते हैं। तो फ्रेंड्स आइए स्टार्ट करते हैं क्वेश्चन। Question is, a body has the cylindrical upper portion of 3 meter diameter and 1.8 meter deep. The lower portion is curved one, which displays a volume of 0.6 meter cube of water. The center of buoyancy of the curved portion is at a distance of 1.95 meter below the top of the cylinder. The center of gravity of the whole body is 1.2 meter below the top of the cylinder. The total displacement of the water is 3.9 tons. Find the metacentric height of the body. Okay, friends. Find the metacentric height of the body. Now, friends, it is saying that let's understand the question first. It is saying that, friends, a body has a cylindrical upper portion of 3 meter diameter and 1.8 meter deep. It means, friends, it is something like this. This is the cylindrical part. Its diameter is equal to 3 meter. Here, this diameter is equal to 3 meter. Okay, friends, this phi equal to 3 meter diameter. Okay, and these have two parts. First part is cylindrical portion and second part is the curved portion. Okay, friends, it is already integrated, but upper part is cylindrical part and its diameter is equal to 3 meter. Its depth is equal to 1.8 meter. Okay, friends, now it is saying that the lower portion is a curved one. This portion is a curved one which displays a volume of 0.6 meter cube. Here the volume of this part, this curved portion, is equal to 0.6 meter cube of water. The center of buoyancy of the curved portion is at a distance of 1.95 meter. This is the center of buoyancy. This is the first part, this is the second part. So center of buoyancy of the first part, a curved portion, is equal to 1.95 meter from the free this surface. Okay, friends, the center of buoyancy of the curved portion is at a distance of 1.95 meter below the top of the cylinder. So top of the cylinder से क्या है 1.95 meter below है center of buoyancy. Okay, the center of gravity of the whole body is 1.2 meter below the top of the cylinder. Means this is the center of gravity of the whole body and it is 1.2 meter from the top of the cylinder. This is 1.2 meter. So center of gravity of the whole body is 1.2 meter below the top of the cylinder. Now the total displacement of the water is 3.9 tons. Total weight of the whole structure is equal to 3.9 tons. Okay, friends. Now the I think it's not there. Find the metacentric height of the body. So we have to determine the metacentric height of the body. Okay, friends, this is the question. It is saying that, hope the question is understand. Now given data is here, dia is equal to what? Dia d equal to 3 meter. This height has given. Okay, whatever distance is there I mentioned here. We have to give some points. This is b1, b2. This is the buoyancy of center of buoyancy of the lower portion. This is the center of buoyancy of the upper part. This is the center of gravity of the whole body, and we should give some point here. This point is top of the cylinder, point is C. Okay friends, here what is lower portion volume has given, it means we should give here this V1. This portion is part 1, so V1, volume of V1 is equal to given 0.6 meter cube. This portion volume is equal to V2, we don't know. Okay friends, and what other data has given? This is the volume, okay, distance, okay, gravity, okay, and weight of the whole body. Total displacement is equal to, so total weight of body, or you can say total weight, W is equal to 3.9 ton. Okay friends, this is the liquid surface. These all are waters. Okay friends, these all are waters. So this is the liquid surface, we can say this is the liquid surface. Getting? Now friends, you see here, we know that weight of the body equal to weight of fluid displaced. हम जानते हैं फ्रेंड्स कि फ्लोटिंग कंडीशन में जो भी वेट बॉडी का वेट होगा उतना ही जो है वो जो लिक्विड डिस्प्लेस करेगा उसका वेट होगा. इट मींस वेट ऑफ द बॉडी इज इक्वल टू द वेट ऑफ फ्लूइड डिस्प्लेस्ड. जितना वॉल्यूम डिस्प्लेस किया है उसका वेट और बॉडी का वेट दोनों सेम होगा. सो फ्रेंड्स, हियर वेट ऑफ द बॉडी इज इक्वल टू व्हाट? Here you see 3.9 ton is there. You can say 3.9 tons is there. Same thing, tons. So what is the weight in Newton? So weight is equal to 3.9 into 1000. This will give the value in kg, and we have to multiply with 9.81. So it will give the weight in Newton. So what is the value here? What is the value? 3.9 into 1000 into 9.81. Okay friends, so it will come here this 38259 Newton. Any doubt friends? Let me explain again. Weight of the body W is equal to 3.9 tons. It means 1 ton is equal to 1000 kg. 1 ton is equal to 1000 kg. So total mass is equal to how much? 3.9 into 1000. So this much kg will come, or we can say kgf force. kgf. So here you see 1 ton equal to 1000 kg, or we can say kgf. Okay, so here total kgf is equal to what? 3.9 ton. W is equal to how much? 3.9 into 1000. So it will give 3900 kgf. Okay friends, 1 kgf, we know that 1 kgf equal to 9.81 Newton. So we are multiplying all these things. So weight is equal to 38259 Newton it will come. Getting friends? Now friends, we know that weight of the body equal to weight of fluid displaced. It means friends, weight of fluid displaced is equal to what? Same, 38259 Newton. Any doubt friends? 38259 Newton. Now we know that here you see friends, weight of the body is equal to what? Weight of the body is equal to weight of the fluid displaced equal to volume of this part and volume of this part. Okay, this is the, because this from here only it is inside the water. Okay friends, or inside the fluid. So here we will consider volume of fluid is equal to what? Volume of this part and volume of only this part. Getting friends? Volume of only this part. So what is the one more thing is there friends, weight of the fluid displaced is equal to what? Rho F, volume of fluid, whatever fluid is there, here water is there, here water is there. So here just to understand, weight of fluid displaced is equal to what? Density of fluid into G into volume of fluid. Okay friends, volume of fluid. Okay, so weight of fluid displaced is equal to what? Weight of the body, and weight of the body is equal to 38259 Newton. So here it will come 38259 Newton. We know that friends, density of water is equal to 1000. So this is 1000 into 9.81 into volume of fluid. This volume of fluid means total volume here inside the water. So it will be equal to Vf1 plus Vf2. Okay friends. So 38259 from here. Total volume Vf is equal to how much? We will divide by this one. So directly we can divide 38259 divided by 1000, or we can say 1000 into 9.81. Okay friends, so it will give friends here 3.9 meter cube. Okay, so this is the total volume from here inside the water. Okay friends, this is the total volume. Now this volume has given, Vf1 value has given, let me write here, Vf1 is equal to 0.6 meter cube. So Vf1 has given, we have to find the volume of this part. So friends, what is the volume of other part? Total volume, we know that total volume Vf is equal to how much it has come? Vf is equal to 3.9 meter cube. It is equal to the, we can say V1 plus V2, or we can say friends, less fluid is there now, so Vf1 plus Vf2. Here also write Vf1, here also write Vf1 and Vf2. Okay friends, Vf1 and Vf2. So we have to find the volume of Vf2, because here you see this Vf1 volume has given 0.6 equal to total volume, this one 3.9. So Vf2 is equal to what friends? Volume of upper part is equal to 3.9 minus 0.6. It will come friends 3.3 meter cube. Okay. Now friends, here you see the dia has given of this one 3 meter. We have to find this H2, height of this portion to this portion, or we can say height of the cylindrical part inside the water, height of the cylindrical part, because from this is the total part of the cylinder of this portion. So total part is equal to how much? Total part is equal to 1.8 meter, but we don't know that how much part is inside of the cylindrical part. Okay, so let this is the H2 height of the cylindrical part which is inside the water. Okay friends, so from here you see that dia is equal to given, so we will find the area. We know the volume is equal to what? Area into height. So pi by 4 into area, dia has given, dia is equal to 3 square. We know that friends, area is equal to how much? Pi by 4 into d square. So dia is equal to 3. So area is equal to what? Pi by 4 into 3 whole square into S2 height. Pi by 4 d square into height S2. Okay. So this is the volume. It is equal to the 3.3 meter cube. So what is the height S2 friends? S2 is equal to this 3.3 divided by pi by 4 into 3 whole square. So it will give friends how much is there? Zero point 0.6. So here this 3.3 divided by how much? Pi by 4 value is 0.785 into 3 whole square. Pi by 4 value is equal to 0.785 into dia whole square. So it will come friends 0.467 meter. So friends, here this S2 height is how much it will come? 0.467 meter. S2 is equal to 0.467 meter. Okay friends, now up to here it is clear. This value we got it. So what is the x value? What is the x value? It means from top of the cylinder to this liquid, how much is there? If let's this value is equal to x, so x is equal to how much? X is equal to total height is equal to 1.8 minus 1.8 minus this S2. S2 total height is equal to 1.8 minus this S2, it will give the value of x. So x is equal to how much friends? This 1.8 minus S2 is equal to 0.467. So friends, the x value it will come how much? 1.8 minus answer, so it will come friends 1.3329 meter. Okay friends, now we have to determine, see here two part is there, part 1, part 2. Here buoyancy force is there, here also buoyancy force is there, but we have to determine the metacentric height, correct? And for metacentric height friends, for metacentric height we know that, let's see here, if this is the thing, this is the buoyancy of the whole body, not b1 b2. Here two things is there now. Here buoyancy of this part, center of the buoyancy of this part, lower part, and here center of buoyancy of the upper part. We have to find the center of buoyancy of the whole part, a total part. Okay friends. So let here, this is the buoyancy of B is the buoyancy of the whole body. G is the, it is given, G is given the center of gravity of the whole body. So this is G. So since it is floating condition, so metacentric of the whole body it will come. So this, what is the value of metacentric height? Gm. Gm is the metacentric height. Okay friends. So we have to find the Gm value. Gm value. For this, we have to determine the center of buoyancy of the whole body. Okay, friends, center of buoyancy of the whole body we have to determine. Now, friends, now you see here how to find the center of buoyancy of the whole body. Okay, how to find the center of buoyancy of the whole body. So center of buoyancy of the whole body equal to center of buoyancy of whole body B. Friends, what happened? How we will find? See here. See here. We will find by this one. Let's suppose center of buoyancy somewhere coming here. Somewhere coming here. At this point, let's suppose friends it is coming here at this point here. This is the center of buoyancy of the whole body. Okay, this is the center of buoyancy of the whole body B. Getting friends? This B1 is the center of buoyancy of the lower part, B2 is the buoyancy of the upper part, but B is the center of buoyancy of the whole part. How can we determine this one? Point B. So friends, center of buoyancy here, you see weight of the water volume is there now. Weight of the volume of fluid displaced. So this is the total volume. Total volume VF is the volume of fluid displaced into distance. Let's see here. Total volume of the liquid into distance. From here we will calculate. From C to B. Okay. Total volume of the fluid displaced into this distance C and B. Correct? Equal to क्या होगा? Volume of this part, first part into distance this to B1, C to B1. Similarly, volume of the upper part, this portion which is inside the water, or we can say VF2 into distance C into B2. So whatever distance we will calculate from the top surface of the cylinder. Okay friends, getting? Let's understand here. So whatever is the for center of buoyancy of the whole body, for so VF is the total volume of fluid displaced into distance C B, because this is the center of buoyancy of the whole body, equal to VF1 into this distance of C into B1. Okay friends, plus VF2 into distance C into B2. C B2. Getting friends? Getting? So we know the volume of VF2. VF2 is equal to, how much is there? VF2 is equal to 3.9. 3.9 is there. So VF2 is equal to 3.9 into CB equal to VF1 is equal to how much? We know that 0.6 into CB1 distance. CB1 distance is the, how much it has given? 1.95 plus VF2. VF2 friends already calculated. What is the volume of VF2? So VF2 is equal to 3.3. This is the volume of VF2. 3.3 meter cube is there. So this is the VF2. So it is volume is equal to 3.3 into CB2. CB2 is equal to how much? CB2 distance not given. CB2, how much is there? Anywhere it is given friends? CB2. The body has a cylindrical upper portion of 3 meter diameter and 1.8 meter deep. The lower portion is a curved one which displays a volume of 0.6 meter cube of water. The center of buoyancy of the curved portion is at a distance of 1.95 meter below the top of the cylinder. The center of gravity of the whole body is 1.2 meter below the top of the cylinder. Top of the cylinder. The total displacement of water is 3.9 tons. Friends, let's understand here. So here not given. We know that friends, here the value has already calculated. This is the volume of fluid displaced, correct now? This is the volume of, height of the fluid displaced. It means this is H2 value has given. H2 value has already calculated, friends. H2 value has calculated. Then we know that what is the buoyancy of B2 distance from free surface to here. From free surface, B2 is equal to H by 2. So this B2 value from the surface we can find here. We can find here the CB2. This is a doubt now, friends. CB2. So CB2 distance is equal to how much? CB2 distance is equal to how much? This distance x plus h by 2, because इसका और इसका डिस्टेंस कितना है? h2 है. अब वी नो डैट कि जो सेंटर B2 होगा यहाँ इस डिस्टेंस के हाफ पर होगा. गेटिंग फ्रेंड्स? So CB2 distance is equal to what? X plus h2 by 2. So from here we are able to calculate what is the value of x2. Sorry, x already calculated here. So x is equal to 1.3329 plus h2 by 2. h2 value is equal to 0.467 divided by 2. This is the CB2 distance. So how much it will come, friends? 1.3329 plus 0.467 divided by 2. So it will come, friends, 0.2335. So total how much distance is there? Plus 1.3329. So it will come, friends, 1.5664 meter. This is the trick. Here we have to find the center of buoyancy of this part. CB2 distance we have to find. CB2 distance we have to find. Now we already calculated here CB2 distance. So CB2 distance already came, friends. CB2 distance 1.5664 meter. Okay, friends. So this value will put it here. If you put it here, CB2 1.5664. Okay. Now, friends, we know all the values. We have to find the distance CB. Okay. So CB equal to how much? Let's calculate here. 1.5664 into how much is there? 3.3. So it will come, friends, 5.1691 plus we will multiply this one 0.6 into 1.95. So it will come 1.17, and here we will multiply 3.9. So from here CB distance is what? We will add this one and divide 3.9. So 1.17 plus 5.1691. Okay, friends, divide by this 3.9. So it will come, friends, 1.625. Okay, meter. This is the CB distance. It means, friends, that the center of buoyancy of the whole body is just below the center of buoyancy of the second part. Okay, here you see CB2 distance is equal to 1.566 and CB distance is equal to how much? 1.625. Now, friends, we are able to calculate the distance of here C from C and B. Okay, so the location, we know that this location of center of buoyancy of the whole body, we are able to find here the distance from the top of the cylinder. So CB is equal to 1.625. Okay, friends. Now you see here, center of gravity of the total body, it has given, we know that. Now center of buoyancy of the whole body, we are able to, we calculated here 1 point, means we know that कि हमने ये भी फाइंड कर लिया है सेंटर ऑफ buoyancy कितना है, g कितना है. Now we have to find the metacentric height mg. So friends, you see here one more point. We are calculating from the top of the cylinder, correct? So from top of the cylinder, this CG distance is equal to this CG distance. This is the center of gravity of the top surface is equal to how much? 1.2 meter, correct? C and G is equal to 1.2 meter, and this C and B is equal to how much? The center of buoyancy of the whole body, CB is equal to how much? 1.625. Okay, so what is the BG distance? The main purpose is that we have to find the distance between B and G. I will explain, friends, why we are calculating here the value of B and G. So the value of BG is equal to how much? CB minus this CG. So 1.625 माइनस कर देंगे 1.2, तो आ जाएगा हमारा 1.625 minus 1.2. So it will give, friends, 0.425 meter. Okay, so we are able to calculate here the distance between B and G. BG distance is equal to how much? 0.425. Why I am calculating this one? Because we know that, friends, the metacentric height is equal to what? This metacentric height GM is equal to how much? This BM minus BG. BM minus BG. So BG distance, we know that from here, BG distance we are calculating here 0.425. That's why we are calculating here. Now what is the value of BM? What is the value of BM? So BM is equal to what? This I list, I minimum, and volume of fluid displaced. So I, we can say I list, a list moment of inertia of the cross section which is at the surface of the cylinder. It means moment of inertia we will calculate whatever surface is there ना. So body का जो part surface से touch होगा उसका हम least moment of inertia calculate करते हैं, और जितना वॉल्यूम जो है वो यह डिस्प्लेस किया है इतना वॉल्यूम हम डिवाइड करते हैं. So friends, I list upon volume of fluid displaced minus BG. Okay, so see here, this is the, here is the cylindrical part. So this is the circle. If you see from top view, this point will come a circle of dia 3 meter. So इसका कितना आ जाएगा, फ्रेंड्स? लिस्ट मोमेंट ऑफ इनर्शिया कितना हो जाएगा? पाई बाय 64 इंटू d to the power 4. So 3 to the power 4 is the moment of inertia. Friends, since it is a cylindrical, so आप किसी भी डायरेक्शन में लेंगे तो सेम ही आएगा. Okay, if it is rectangle, then least moment of inertia will be सब different, maximum and minimum आएगा उसमें. But cylindrical means every side it will give the same. That's why pi by 64 into 3 to the power 4. And volume of fluid displaced, total volume of fluid displaced कितना है, friends? This is the total volume which is inside the water is equal to 3.9. So divide by 3.9 minus BG value already calculated here 0.425. Okay, friends. So we will calculate all the value here. This is pi into 3 to the power 4 divided by 64. So it will come 3.976 divided by 3.9 minus how much is there? 0.425. So friends, if you divide here, divide by 3.9 it will come 1.0195 minus 0.425, or we can say directly minus here 0.425. So it will come friends 0.5945 meter. It means friends the metacentric height is equal to, it will come 0.5945 meter. Since it is positive, so body is in stable equilibrium. If the value has negative, so it is unstable equilibrium. So friends, whatever metacentric height will come of this body, we know that we are able to calculate here. In doubt friends, you can ask me in the comment box how much is there, any doubt, any point, you can ask me. I will try to solve the doubts. सो फ्रेंड्स, मेरा एक्सप्लेनेशन अच्छा लगे तो प्लीज़ मेरे वीडियो को लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए फ्रेंड्स। थैंक यू।